Welcome to this video which focuses on Year 7 Unit 6, Make Code. Now both in primary school and earlier this year, you had some experience of using Scratch. Scratch is a block-based visual programming language, and it's a really good introduction to the idea of putting sequences of instructions in order to make something happen. Now Make Code makes use of the same type of block-based language to this time operate a device which is slightly different. Now your teacher will have made available to you in your content library the Make Code main tutorial page. It's important you have that available, and we're going to have a little bit of a look through that now. Just below the main title you have learning objectives. Immediately below that we have some key terms, and here we're going to pause for a second. Now reading these key terms yourself are really important, but I want to focus in on these three. Sequence, first of all. You should be aware already that programs are made up of sequences of instructions. Instruction 1, Instruction 2, Instruction 3, and so on. They operate in that order. So when we're talking about sequence, we're literally just talking about operations being placed one above the other. However, that only works for very simple programs. For more complex ones, we have to introduce selection. Selection gives the computer the opportunity to find out whether something's happened or make a decision. And if that decision happens to be true, it will follow a different sequence of instructions than if the decision had been false. These are often represented using if statements. Another common thing programmers need to do is to repeat a set of instructions, so that's where we have iteration. We can either run iteration for a fixed number of times, like running something 6 times, or we can continue to run until something happens. Now you'll be using these three constructs as part of your programs, and one of the real purposes of this task is to make sure that you can identify and label and write down your evidence for using sequence, selection and iteration. Now you're going to be using a device called a Microbit. We have some of these in school, and by the end of the unit you'll be able to actually load your code onto one of these and actually try them out for real. But for most of the unit you'll be using an on-screen simulation to program your work. However, to introduce us to the Microbit, let's watch a little video.
The Microbit is a pocket-sized computer that lets you get creative with digital technology. You can code, customize, and control your Microbit from anywhere. Light up the LED display to create something simple in minutes, or even communicate between Microbits. Or get really creative with Microbit's more advanced features, like its buttons, motion detector, compass, and sensors. You could create a guitar that changes the volume the more you shake it. Or a flick football game that powers a Microbit scoreboard. And you can connect it to other devices, sensors, and everyday objects. So you could water your thirsty plants, or use Bluetooth to take photos with your phone, and control your music player. And you can customize the Microbit in any way you can imagine. It's really anything you want it to be.
I think to be like a robot.
It's quite different to any other technology I've sort of used before. You just have fun with it.
I can control my tablet.
You can make games, you can take pictures.
Kind of something that senses movement.
And you can just place it in your pocket and make whatever you want.
We'll describe it as a
future.
Now for this unit we're going to be focusing on a series of tasks, 2 introduction tasks plus an assessment. Task 1 asks you to go off and actually look at the Microbit and look them up online and find out what the different parts are. You're given 2 diagrams in your workbook of the Microbits front and back, and the idea is to label what each of these parts are. Now in order to add your annotation to this diagram, just click somewhere on the right hand side, type in your response, and then grab hold of the top of that text box and drag it as near as you can to where you want it to go. This may or may not be a correct answer. Then you can click and type another one. The Microbit has lots of facilities in it that make it work as a device. These are some of them, and the idea is to write down what those things actually mean. Make sure, for words like radio, that you actually write down what they mean in the context of being on a Microbit. rather than something that old people listen to the news on. Now back to the main page, Task 2 focuses on a dice game tutorial. Now this asks you to click on a link that takes you to the Microbit page. Let's have a look now. Now the Microbit main page has a huge number of tutorials, exercises and practical activities that can be done with these devices. We're going to be initially focusing in here on these tutorials. Now you're welcome to start off with one of the simple tutorials if you wish to, but the idea is to move on to the dice tutorial as soon as you think you're ready. Now there's a video lesson on the left hand side which you can play if you're not quite sure, but we recommend just clicking on this start tutorial under blocks. And this will launch the Microbit editor with a copy of a Microbit over here on the top left. The tutorial steps appear here at the top, and when you complete each of the steps, you can then click on to the next step. So simply follow your way through. So as with Scratch, you have different sections down the side, and as the tutorials progress, you'll be given more of these sections to play with. Click on the section and pull out the block that you wish to add in. And then when you've completed the instruction, click on Next, and it will take you on to the next step. And I need to press the little shake button to make the code run. Now, if you want to keep a copy of your project, you can press the download button at the bottom. Your computer will download a hex file, and returning to the computer, you may well find that you can still see your projects from before, but if you go to a different computer or you load up your machine at home, you can press the import button on the top right and select the hex file that you've just saved and upload the project to carry on. And you're back where you left off. Now the dice tutorial is essential, but you can try any of the other tutorials and then try one of the game tutorials as well. We've got two places for you to record evidence for your dice game. A screenshot of your overall code will go in this box, and then underneath, in writing, explaining how your code works. This is a simple tutorial, but it's important your writing explains in as much detail as you can how the code works. Now below that, an explanation of our PRIM principles of programming, focusing on tasks that allow you to predict what an existing piece of code will do, to run the code using the tutorial, to investigate how the code works, to modify the code, to make some changes that make the code different from somebody else's, and then finally making your own game related to or different from what you've seen. So task 3 focuses on the rock, paper, scissors tutorial. In your workbook then, we have the predict, run, investigate and modify tasks listed for you to do. First thing, predict, starting off by writing down what you think the program will do, and then working through the tutorial, putting a full screenshot of your code in this place. Under the investigate, we want you to explain how the rock, paper, scissors code works, using the programming concepts we've discussed already. We then want you to play an experiment to produce something that's different from the original code. Anything will do. The programming challenge gives you freedom. You can essentially use what you've done to try and create something completely original yourself, or based on one of the tutorials provided, but again, making sure it's completely different and adds in additional features. We suggest for the programming challenge that you spend a bit of time exploring some more of the tutorials between lessons for homework. The Programming Challenge workbook gives you space to record your evidence and explain in words exactly how your code works, plus add in some extra originality of your own. So the very best of luck with your assignment, and we hope that we see some really original ideas on how you can use these simple but very, very powerful devices.